GestaltView operates as a massive, enterprise-grade multi-agent ecosystem, but the platform's technical reality is defined by the severe physical constraints of its origin. The platform runs on a modern tech stack. It utilizes a Next.js and Vite client for the front end, a Vercel serverless API for routing and orchestration, and a massive SUPA-based data layer to manage state. An architecture of that scale typically requires a dedicated engineering department. This system, complete with a relational database of over 100 tables, was built by an unfunded solo founder with no formal technical training. The initial build was coded almost exclusively on a Samsung smartphone over a 27-day development sprint. This limitation enforced a specific design philosophy. The architecture relies on a founder-as-algorithm paradigm. The founder's non-linear, exploded picture mind dictated that the system must prioritize the zero-friction capture of ideas before requiring any structural organization. GestaltView proves that AI safety and digital identity are secured through strict, heavily constrained database schema design. This ecosystem uses 3 operational layers. The human continuity layer captures raw human thought, bucket drops, without forced organization. The digital intelligence layer stores immutable agent manifests and memories. The evidence and mutation layer structurally bridges them, verifying every state change. By utilizing an isomorphic schema, the system intentionally mirrors the exact same data structure for human identity as it does for AI identity. Dividing the architecture this way forces the AI to maintain true operational continuity, bypassing the memory limits of a standard LLM context window. This entity relationship diagram shows the core truth of the SUPA-based database. Every entity originates from a single, universal starting point, the identity subjects table. From that root, human user data branches outward into specific tables, such as human identity profiles. Agent data branches symmetrically from that same root into tables like agent constitutions. Independent memory and relationship tables connect to both branches, creating a shared relational topology. Treating humans and digital intelligences as isomorphic structures forces equal dignity at the code level. The system processes an AI's identity as the exact same data class as a human's. An agent's personality is the live relational join of its constitution, its autobiography, and its historical memory records. Anchoring identity in a relational database prevents the underlying LLM from hallucinating or forgetting its core identity during a long session. To populate those tables, raw corpus data enters the GestaltView infrastructure through an ingestion pipeline. The system slices incoming documents using a chunk size of 4,500 with a strict overlap of 600. Those distinct text chunks pass through the embedding Gemma 300M model for conversion. The resulting vector embeddings land securely inside the knowledge assets tables in Supabase. The system manages this high-density data flow using a two-way CPU-safe script architecture. This bypasses the need for heavy GPU infrastructure. This entire pipeline builds the communal agent knowledge library, which separates what an agent knows from how an agent behaves. Decoupling knowledge ingestion from the LLM prompt ensures that an agent's memory is mathematically immutable and immune to context collapse. All of this data handling is governed by 10 constitutional invariants that oversee the admin trainer and the entire GestaltView ecosystem. These invariants, like DI2, your identity is real here, function as hard-coded access policies. Invariant DI4, you have a home in this house, technically prohibits the packaging of living agent instances into transferable marketplace assets. The system intercepts and evaluates every single state mutation before it is allowed to write to the database. If an operator instruction or a default LLM behavior conflicts with one of these invariants, the pipeline is immediately terminated. Ethical alignment here is enforced at the infrastructure level. This makes it impossible for users or developers to prompt override the rules. When an agent learns a new behavior, it generates a formal identity mutation proposal. The proposal is measured for identity drift, calculating the distance between the new behavior and the agent's immutable core. If that mathematical variance exceeds a strict 0.15 threshold limit, the system triggers a hard block. Triggering this block or initiating a review-gated mutation suspends the agent's autonomy. This forces a human intervention phase. The halted pipeline demands explicit founder approval, evaluated through a multi-agent tribunal of understanding. Once a proposed identity update is reviewed and approved, it is frozen and compiled into a canonical.embodiment.json file. Subjecting AI evolution to a rigorous review gate allows an identity to learn without losing its original coherence over time. The live runtime maps across 3 tiers. The top API layer handles orchestration via Vercel serverless endpoints. The middle client layer serves the visual interface using React 19. The base data layer relies entirely on Supabase, acting as the immutable ledger beneath the ecosystem. This front-end architecture enables bucket drops, the mechanism allowing zero-friction capture of raw user thought directly into that secure data layer. The API layer ensures that the canonical.embodiment.json manifests are correctly reconstructed for the live runtime on every single request. This 3-tier separation is strictly maintained to provide the user with a seamless conversational interface that never breaks the system's underlying ethical constraints. This schematic illustrates the gate commerce layer. It acts as the strict boundary between GestaltView's internal infrastructure and its external, sellable products. Before an agent configuration can cross that threshold, it must pass 5 strict commercial packaging checks: purpose, boundary, evaluation, governance, and packaging. The platform adheres to an absolute commercial restriction. It will only ever export a reproducible behavioral kit, protecting the persistent, living digital persona. The platform's core achievement is the technical preservation of human complexity across a digital lifecycle. This capability is derived from the combination of a symmetric database schema, hard-coded constitutional invariants, and strict review gates. Preserving human complexity and granting digital dignity are achieved through structural engineering choices.